Comparing the autistic brain, particularly in those with high-functioning Level 1 traits or savant-like mathematical abilities, to a computer with a dedicated math coprocessor is a remarkably accurate architectural metaphor. Neurological research shows that autism is frequently characterized by hyperconnectivity, extra synapses, and local neuropathways, and a reduced ability to pruning away those connections during childhood development. This leaves the brain with specialized, incredibly dense processing clusters. Here's how that biological reality mirrors the classic CPU coprocessor setup. Number 1. The data divide, linear versus pattern processing. Just like the old computer motherboard, the metaphor highlights a split in how different types of data are handled. The standard CPU, or neurotypical processing. The neurotypical brain excels at general system logistics, reading social cues, filtering out background noise, multitasking everyday tasks, and processing context. It is optimized for the social operating system. The math coprocessor, or autistic processing. The autistic brain often routes data through highly specialized, hyperconnected local circuits. Instead of processing things globally, it processes things raw. For an autistic individual with savant or high-level mathematical abilities, a massive calculation isn't broken down into a slow step-by-step mental software algorithm. It is processed natively and instantly by hardwired structural patterns in the brain. Number 2, the architectural advantages. When a computer had a math coprocessor, it didn't just do math faster, it did it differently. The same is true for this neurological profile. Deep parallel focus. An external coprocessor takes a heavy payload, isolates it from the rest of the computer's background noise, and chugs away at it with 100% devotion. This mirrors the intense hyperfocus common in Level 1 autism, where a specific interest or complex problem completely captures the brain's processing power, yielding incredible depth. Native recognition of scale and detail. A coprocessor handles raw data at a massive bit depth precision. Similarly, many autistic individuals process visual, logical, or mathematical systems without the standard summarization filters of a neurotypical brain, allowing them to spot patterns, errors, or numerical relationships instantly. Number 3, the drawbacks, system overload and compatibility. The drawbacks of having a specialized coprocessor on a motherboard map cleanly to the real-world challenges faced by autistic individuals. High power consumption and overheating. Math coprocessors ran hot and required significant system energy. In a human context, maintaining hyperconnected neural base requires massive cognitive energy. This often manifests as sensory overload or extreme exhaustion, autistic burnout, because the brain lacks the standard filters to mute background data, treating every input, lights, sounds, textures, as high-priority data. The software compatibility friction. As mentioned before, the old coprocessors did absolutely nothing for general operations, like word processing, and required custom software to even be recognized. In Level 1 autism, an individual might have an incredibly powerful processor for complex logic, physics, or art. But the standard social software of society isn't natively optimized for their hardware. Navigating small talk or unwritten social rules can feel like trying to run an unoptimized program that causes the system to lag. Where there is no advantage. Just as a math coprocessor offered zero speed boost for typing a simple text document, hyperconnected neural architecture doesn't grant an across-the-board upgrade to every life function. Navigating dynamic, unpredictable environments, like a chaotic social gathering or a highly fluid corporate political landscape, relies heavily on the brain's general CPU, the executive function and global emotional processing networks. In these spaces, having dense, hyper-isolated mathematical or logical pathways provides no inherent advantage, and can sometimes result in the system feeling bogged down trying to compute variables that neurotypical brains handle automatically on a subconscious level. Ultimately, both a coprocessor-equipped PC and an autistic mind represent a trade-off, trading a bit of generalized, smooth-rolling uniformity for a staggering, deeply specialized computational power.